Right, next eBay purchase. This was actually came as a pair with the last radio I repaired. Where the last radio was really dirty, this one is almost like new. It's only a couple of years old. It lights up perfectly, display looks good. The only problem is she's dead, Jim. TX light comes on, but that's about it. No real sound on receive. I don't know. I mean, the front panel was just about perfect. You know, it's looking really good. It's looking really good, Nick. But it's got these marks all over it, which are really odd. And I've tried getting off. It's like, I don't know, plaster or something. I'm not quite sure. You have to sort of scrape it. So once I repair it, I've got to try and clean all this off and see how that goes. But right now it's a bit yuck. The bottom side's actually worse. Yes, fingerprints and everything over it. But apart from that, it actually looks really good. So I can clear that gunk off the outside, then and repair it, of course. That'll be right. So now, I've already unscrewed the covers. Let's put this one off. And as expected, pristine. I've had a quick look around already, and I haven't seen anything out of the ordinary. I haven't opened the other side up yet, but on this side there's nothing I've seen which looks bad. There's a little bit just here, which is probably just a little bit of flux or something. You know, it's got a little bit hot for some reason, but that's the only kind of key I've got. So I haven't done any actual testing yet, apart from keying the mic. So I'll be doing that soon. I'll be hooking my scope up and just checking for frequencies and see what's there. My guess will be, well, the fact the TX light is coming on means a PLL is probably working. It could be a mixer, it could be a blown RF chain. I haven't tried to receive yet, although I can right now. Let's try to receive, that will illuminate a lot of things. No receive. There's the arrow. Can't see anything there. Yep, so no receive. So it's likely to be a PLL or mixer issue, and we'll go from there. Right, I just started probing around. I'll just cheat here a little bit. Let's get the cable out of the way so you can see. I'll stick that in there. Signal there. Crystals are slightly. Ignore the frequency, it's because it's a bit weak there and not probing properly, but I just want to confirm it's actually there. And I've also probed here, down this end here at the back, checking for a transmit frequency. There's nothing. So I actually need to go back further and check VCO and PLL and see if they're actually working. Right, so let's do a quick voltage check. So PLL, pin 1 is the DC supply. So right there, 8 volts. Okay, so the PLL is getting power. Phase detector output from the PLL is pin 7. So it's 1, 2, 3, 4, 5, 6, 7. That one there. 4 volts. So there's power coming out to the PLL. Let's just change channels and to the other end of the scale, back onto that pin again. 3.9 volts, the same. So the frequency of the VCO isn't changing, otherwise that voltage should be changing. So it's PLL or VCO. So let's just do another little test. Let's just check the frequency that's going back to the PLL, which is pin 9. That one down there. So there's a frequency there. 17.2. Let's just turn the amplitude up slightly. Yeah, it's still the same, definitely triggering enough. So 17.27. That's channel 40. Channel 1. Same. So the VCO frequency isn't changing. This is always the tricky bit. Is it the PLL sending the wrong voltage, or is it the VCO that's stuck? So I just need to go back and figure out which way is the problem. There's two ways of doing that really. You can either inject a different frequency into the PLL, or you can inject a different voltage into the VCO. And injecting voltage is usually easier. So I'm going to have a look at that next, and just in little probe around there, just make sure what frequencies I'm getting in there. But yeah, it seems the VCO isn't working properly. It's not controlling voltages. I do notice there's a an empty diode hole there. D11. I wonder if that's related. Let me have a look on the other side of the board, because that is also happens to be a VCO diode. It's a VCO diode marking. See, it looks like a capacitor with a diode, which could be the VCO control. Let's have a look here. Right. Whereabouts is that supposed to be? Let's just try and line that up on the board there. Right. Where are we there? Between there and there, that's two pads. So there is a little diode right there instead, service mount instead. So just there, service mount diode. So yeah, that looks intact. I might just have a really close look at that though and see what's going on. Right, so to test this VCO/PLL issue with the frequency control, trying to determine which one is that fault. I'm doing a bit of a cheat way really, I suppose. This is just trying to inject a voltage. There's already a voltage here at the PLL, right? So it's already trying to generate what, 4.1 volts. But there's a resistor in series with the output, right? Just there. So that pair of pads right there, the tip of my finger goes across from that side to that side. So what I've done is I've just put a little wire on for now, tacked it on, and I'm putting it through there. There's a 5.6k resistor, so what was it, 4.7? Sorry, 4.7k resistor. And I've just put it across to the chassis here. So I'm going to use my little resistance thing here to shunt 0 volts across there. What I'll do is gradually reduce the voltage of the phase detector effectively, and which should cause the VCO to change frequency. So what I'm going to do here is just going to probe the phase detector input, which was pin 9, wasn't it? Pin 9 right there, and the frequency there. It was 17.24 megahertz before, now we're getting 17.78, and that's with 4.7k across it to reduce the voltage down to. Give me a second. That reduces the voltage down to, before I get the probes on, at that point there, 3.2 volts instead of 4.1. So 1 volt difference has increased that frequency, which you can't kind of see because I haven't got a probe on. Right, so now I'm just going to reduce this a little bit more. Okay, I'm just going to go down. Let's go 2.2k. I don't want to go too much with it because I don't want to overstress the PLL output. But the idea is to tell me whether or not it's the PLL or the radio which is at fault. So I'm just going to probe this again to see what voltage you're getting now. Now getting 2.2 volts. Okay, so which is a reasonable voltage for a PLL output, or PLL control. So let's just get the camera over in the right place. I'm trying to do two things at once, it's not good. Okay, going to probe on there. Still frequency 17.88. Okay, so the VCO is changing frequency. Right, so still not transmit, but so that's actually working. So I might actually just try adjusting the VCO, just in case that's all it is. I mean, it still looks like it's sealed from the factory, so I'll be very surprised if it's a VCO adjustment, which is what's gone wrong. But I'll try adjusting it and see if that brings it in line or not. Right, so I've given it a VCO tweak and no improvement. What I've actually did, the VCO frequency should be 16.725 megahertz, so I've got that on the frequency input again. So I've tuned all the way down to 16.25 without much change. Actually, what I'll just do, I'll just stick the probe on there. Hold on a second, I'll just do this differently. Let me just make life easy for myself by using a hook. That'd be far easier instead of having to probe it. Let's just hook that on. Right, there we go. Now 16.25. Let's just adjust this VCO. It should be 16.725 on channel 1, which is what it's currently on, channel 1. So if I tune the VCO to be that frequency, then that should in theory be working. Right. It's not locking at all, see that? It should be locking if it's there. So it's really not working. So yes, more investigation required. So I might actually just check the phase detector output from the PLL and see if that is changing. If the phase detector changes when the frequency is lower instead of higher, then it if it goes to a lower voltage instead of 4.1, it'll be 0 volts or half a volt or something. Then I know that the PLL was trying to control the frequency. So we'll give that a go. Right, so just improve my setup a little bit. Stuck a probe on there so I can actually hold it all. So it's still doing 4.1 volts. 16.387, so that is actually showing me that the VCO is likely, or the PLL is not likely to adjust the output. So between those, see if I go higher than 16.725, so that's above where it should be, still the same. So it looks to me like the PLL might be dead. That's my suspicion, because it should be changing output voltage if the input frequency is above or below the correct one. So I suppose I could check the binary input into the PLL to make sure it's getting the correct channel number going in, because the fact there's no transmit at all means the lock detector's turned on, which means it won't actually transmit, it's locked out, it's disabled itself. But it doesn't mean it's not working. So I should check the lock detector, because that should be disabled, and I should check the binary going into the PLL to confirm that binary is correct, because if the binary code going to PLL is wrong, it will lock itself and it may not work. So I should do that to rule that out as well. Okay, so let's just measure the lock detector, see what's actually going on there. This is on pin 4, and that is low, 0.4 volt, which means that the PLL has sensed it's not on frequency and it's unlocked itself. So that's disabling the radio. Okay, so the PLL might be okay. So let's just see what's going on here. Let's just see if the binary codes are correct. Let's go around all these. I'm on channel 1, so the binary code should be 0. So that's low. 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 And that's low. So the binary code going to the PLL is correct. So it's not like a child selector fault or a short on a trace somewhere. So at the moment it doesn't help much. PLL is unlocked. PLL should be trying to control the phase detector. It isn't. Likely the PLL. That's where I'm leaning right now. Likely to be the PLL was failed. Because I know by injecting a voltage into the VCO, it is changing the frequency. And it's adjusting through the frequency range correctly. So I think the PLL's died. So I might just try resolder it in case there's a bad solder joint on the PLL. That can happen. They look okay, but it doesn't mean they are. So I resoldered the PLL, since it's likely to be failed anyway. So let's just try that and go from there. So I've resoldered the PLL, no difference. So I might just leave that for now, because of the ROM nature of the PLLs in essence. They're not normally convertible. Just turn it off so you can hear me better. Right, so they're not normally convertible because of the nature of the ROM and the PLL. You can't just change the binary code and change the frequencies. It doesn't work like that. And you can't also just inject another signal because there is only one 10.24 right there. That's your only signal. So it does some really clever mixing and stuff in there in the radio, and it generates frequencies quite nicely. So anyway, however, I have a modification board which I use, which I designed, and based on something similar I've seen, and it converts the radio, actually replaces the PLL with another one. It's a design which I saw many years ago, and basically I managed to reverse engineer it and use it myself. So I don't do many. I've only done half a dozen probably ever since I designed the thing. But yeah, that replaces the PLL. So that I might just have to just do that conversion and hope for the best. I don't want to waste my time converting a broken radio, but this radio is in quite good nick, so I think it's likely to be repairable. I suppose I could just try changing the PLL. There's a few things I can try first. I could try disabling lock detector, just to see if I can get the thing to transmit. I might do that first, just to verify it actually works in those other areas, and then I'll look at. I think I do have one of these PLLs lying around, so I might just drop one in. Okay, so what I've just done initially is I've just desoldered that pin on the PLL, pin 4. That's the lock detector. I know if you just disable it by desoldering the pin, you don't actually have to do anything else. You don't actually need to inject anything else, because it pulls it down to shut it off. So if you just disconnect it, it keeps going. So that way it ignores any errors and just lets you use the radio regardless. So with that, I am now getting a transmit. Let me just get some more test gear on so I can actually see the frequency. It's obviously way out of whack right now because the VCO is not tuned, but let's have a look. Okay, so it is transmitting. So let's just wind this back in a bit, just to change that frequency a little bit. Try again. There you go. So it is transmitting. So that part of the radio is working, which means I probably need to replace the PLL. So I'll just do that next and just eliminate that as a cause. If once I know that if that's the problem or not, then I'll decide whether we're going to put a mod board in it or not. Now, for desoldering, I just use one of these little hand pumps. They've always been fine for me. I would love one of those proper desoldering stations with a vacuum pump and stuff on the handle, and that'd be really nice, but one day I might get one. Anyway, a little tip for now: when you're desoldering stuff like this, if you're not sure if the pin is actually off or not, just get the soldering iron tip, straight there. See it moving slightly? Okay. Just a little bit. Okay. Little wiggle. Now just stuck a little bit, but that's okay now. I think that's off now. See that moves? So what I do. Just tip the soldering on, give it a little wiggle. Yeah. All fine. So those ones now are stuck. There we go. Now it's off. It's off, 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 off. That's all fine. So sort of carry on with the other side now. Then I'll get the PLL out, drop another one in, and see if that resolves the fault. Here's my PLL collection. I've got a few. Yeah, I've got a small collection of various ones in there. They came in handy. It was brand new and yeah, awesome. So yeah, I'll drop another one in. See if that fixes it. Okay, the chip is out. Here it is. Just there. I'm not going to assume it's blown yet. Not yet. So I'm just going to look after it. Because I dislike soldering ICs so much, because it can be a pain. This one's come out quite easy actually. I tend to install sockets. Because once it's out, just put a socket in, have done with it. You know, if it doesn't work, you can always unplug it, plug another one back in. I'm also loath to put in a brand new PLL if I'm going to be taking it back out again to do a conversion later on. So I don't really want to solder all the legs up and then take it back out. So this is really just for troubleshooting purposes at the moment. So what I'm going to do is going to put a socket in there. I'll install the socket because it's just a socket. Who cares? You know, it's worth 50 cents or something. And put a socket in, drop the PLL in, a brand new one, see if it works, and go from there. Okay, I'll just put the new IC in, so that's the left and PLL. Let's give it a try. Alright. Let's see. Oh, power. 26964. That's on frequency. Do you know 40? 404. There we go. The PLL was blown. So that is that fixed. This little bugger here was the problem. So now you've seen how to diagnose a PLL and you know what process to use, because it can be confusing because there's a loop. And you have to know how to affect the loop to determine what the loop is doing. Let's turn that filter off again. Just a note, I have a filter, right, for soldering. You need to use a filter for soldering. You really need to use a filter for soldering. It's not good to breathe that stuff in. So yeah, so as I was saying, because it's a loop, you have to determine which part of the loop is causing the problem. Is it the wrong voltage going to the loop, or going to the VCO, which is causing the wrong frequency, or is it the wrong frequency which is causing the PLL to put out the wrong voltage? So that's why I did that test initially. The very first thing I did was to inject a different voltage, well, to modify the voltage that's going to the VCO in order to determine whether or not the VCO was wrong or the PLL was wrong. And because the VCO frequency was changing, there's a good chance the VCO is okay. Sometimes they do fail, like if a diode fails completely, you can't adjust the voltage. Well, you can't adjust the frequency by voltage, it just doesn't do anything. So that proves the VCO diode was okay. And the fact that the frequency going into the PLL was above or below the frequency it should have been, which is 16.725 megahertz on channel 1, and the PLL wasn't adjusting its phase detector output, told me that the PLL probably was faulty, because if it's above the frequency or below it, it should be trying to either increase the voltage or reduce the voltage to control the frequency, and it wasn't doing that. So that made me think it was the PLL as the main culprit, and sure enough, substituting the PLL all sorted out. Obviously when I soldered the socket in, I re-enabled the log detector because I soldered that pin. So yeah, so the radio is now working again, so it wasn't too bad. And what I'll be able to do now is look at doing a conversion board for this, converting it into channels, so it can be used in my country. So that was the plan. It was either going to be an easy repair, well, an easy-ish repair, or a parts radio. So, because a lot of parts on these are same as like the 29s and things like that. So, all good. That's that radio done for now. I'll do another video later on showing the conversion, probably. I expect I will. So, done. Another one for YouTube. Also, before I forget, one of my diagnostics is a piece of software I wrote, which is available to buy. Actually, you can buy it. Basically, it's a simulator. So you come over here. It gives you the binary code, loop frequencies, mixing frequencies, that kind of thing. You select a PLL up the top here. So these are the ones I've programmed into it. So these are the ones it supports. 25 limited is the actual marking, but it's actually a is it C132, I think is the actual part, but it's got reversed binary code. So it's reversed, so it's inverted. Anyway, so 25 limited, and this is what it tells you. So it tells you the IF frequency, it tells you the VCO frequency, which is feedback, and downmix frequency is what feedback. So downmix is the same as the VCO in this case, and it tells you the channel frequency. You can actually change things. Here's the actual simulator, which tells you more detail, like a block diagram, showing you the mixer frequency. Now, the makeup like is a block of how it works, to show you how you work it out. And from here, you can actually change the channels and generate different frequencies. So you can see what all the frequencies are for every channel of its normal operation range. And here's an encode list, so you can see what the binary code into the PLL is. So I use this as a troubleshooting tool. So I wrote it for myself, really, and released it for licensing and stuff. So it's called DEFPOM CB Simulator. It is available. If you go to snmsoftware.com, you'll see it there. So, or just do a search for it, you'll find it, I'm sure. But if you're interested, I mean, it's got, because these have, I'll show you something. Because the PLL is direct mixing, you've got TX and RX frequencies, which are different. These down mix is different, so it offsets it. So it's a thing to watch out for too. So, 16.27. So I was saying 16.725 before. 16.27 is the frequency it should be using. Anyway, I adjusted VCO through that range, didn't work, so I know it definitely was not that. So, and there's a PLL pinout as well. So this is the pinout of the PLL. So if you need to reference which pins you need to check, it's all right there. This actually came from one of those awesome books by Lou Franklin, PLL data book. If you can get it, buy it. If you don't have much understanding, even as a reference material, it's brilliant. Any of his books are brilliant. His books. So this is from his basically, and I've just inserted it in here for me to use. This is a nice, quick, easy reference. Instead of having to go and dig a book out and try and find a page, I just, just come over here, select the PLL you want to look at, and this is actually even more than I've got in my other list. Yeah, I'll put everything in there I knew about at the time. I'm sure there's some more now, but yeah, so that's that little device. And there's also encode converter. So if you got convert a decimal binary hex, you can just do that quite easily. Like it's handy if you're doing, well, I used to do EPROMs, so it's handy for that. So if you want to, say you've got a binary code of 123, well, decimal code 123, there's your hex and there's your binary, easy. Anyway, I thought I'd show you that too.